so the topic of today's lecture is we're going to finish off the teeing stuff, and then we're going to talk about file permissions and things called expansions. All right, so yesterday we ended at, we were talking about tees. So just to quickly remind you, we talked about redirection in piping. So when you redirect the output or input of a command, you can, when you redirect the output of a command, you send the output of the command to a file. Piping lets you send the output of a command to the input of another command, and often it's useful to do both. And the way you do both is to use a tee. Okay, so tee is a program that, oh, that's not right. Oh, that was neat. Sorry. All right, tee is a program. So tee is just a regular program. So it has input. You can take the input. You can take the output from a command, send it to tee. Right? Tee will take that input, leave it unchanged, and send it to its output. But at the same time, it will also redirect whatever the input is to a file of your choosing. So just a second here, I'm going to turn this camera. Okay. All right, so we did these examples yesterday. I'm not going to take the time to do them again. You can use as many tees as you like. You can even connect a tee to another tee, but that really doesn't do anything. So that's not terribly useful. But you can insert a bunch of tees. If you have a long pipeline, you can insert tees anywhere into the pipeline so that you can record the intermediate results. Right? This is often useful when you're debugging. You're debugging a pipeline. So you write a long pipeline, it doesn't quite do what you want it to do. So it's useful to be able to see what's happening in the middle of a pipeline. Right, so here I can take the, I can run the command fortune, send pipe its output to tee. Tee will save the output of fortune to a file called text. And it will send the output, and it will send the output from fortune onto CISC. Right, CISC will pipe into tee, so tee will save the output of CISC to cow.text, and we can actually send CISC to CISC again, which is interesting. So let's try this and see what happens. So we'll do fortune. You know what? I'm going to make a directory. So probably have one. I'll just call it something like this. Yeah. Okay, so I'm going to take fortune. I'm going to send its output to a tee, right? Using the tee, I'm going to save the output of fortune to a text. Then I'm going to send it on. I'll say I'm going to take the output of CISC and send that to a file. If you have a long line, you can use the / to break the line. I'm just going to, oops, sorry, I'm just going to keep on typing because I actually have room. Oh, sorry. So that's what happens when you run that pipeline. I'm going to then send the output of CISC to CISC again. Oh, sorry. I think that -n is a, there we go. Like that. That -n is a typo. I have to get rid of that. So here we've got fortune. We sent it to, we saved the output as fortune.text and then passed it to CISC. Right, CISC, we saved the output of that to cow.text and then passed that on to CISC again. Right, so here you've got a cow that's writing the output of another CISC program. And you can see it doesn't quite work properly. So in other words, it loses the formatting of the cow when it prints it. If you want, you can then go look at the output of the original fortune. So that was why was Stonehenge abandoned. It wasn't IBM compatible. and you can look at the output of cow.text. So you can see there you've got the intermediate results saved. Why is that? Sorry, I just want to get rid of that. Okay, and so that's all you need to know about a T, right? So a T just lets you split. A T literally splits the output of another program so that you can send it on down to the pipeline while also saving the result to a file. And that's really all you need to know about Ts. It's also all you need to know about pipelines for the time being. You need to get some practice writing pipelines before you become comfortable. All right. Now, everything in Unix or Linux or any Unix-like OS is centered around the file. So files are a fundamental part of the operating system. You can see that, so with the Ts, you can see that often you save the result of commands to a file. Now, the other interesting thing about Unix like operating systems is that they were designed at a time when a computer was extremely expensive. So you wanted the computer to, because you couldn't afford to buy a computer for every employee, right? The way it used to work is that employees would remotely log into a computer, and you'd have many users on the same computer at the same time, right? So in other words, the Unix-like operating systems were designed for what's called multi-user systems, right? They're also called multitasking systems. So that means that many tasks are happening at the same time, which isn't surprising if you've got a bunch of users on the system at the same time. Right? Typically, users would log into the computer over a network, right? Now that computers are quite inexpensive, this is less common. So it's less common to have a big central computer somewhere where lots of people are logged into it at the same time. Although that still exists, so there are still organizations that have a big centralized computer somewhere, or several computers somewhere, where multiple users are logged in at the same time. But it's less common in today's world. Now, for this to work, right, if you've got a bunch of people logged into the computer at the same time, there needs to be some mechanism in place that protects users from each other and that protects the operating system from normal users. Right. For example, if you have two different users on a computer, then user one should not be able to modify or maybe not even see the files belonging to user two. Right? So there's this aspect of privacy that you have to be concerned about. And then similarly, there's also a notion of what users can do, right? Depending on their role. So a regular user should not be able to modify any of the operating system files that are critical to the OS. So there's also that aspect that we need to consider. All right, so a user can own files and directories, right? So directories are just files anyway, right? So really a user can own files. Now on Linux and on most Unixes, so a regular user owns their directory and all of the files inside their home directory, right? So under this directory called home, right, you can see that there's only one user on this particular Linux installation, so that's my directory right there. Now I'm going to show you the output of ls, the long listing format, right? So if I write ls -l, then I get what's called the long listing. I didn't actually need the -a here. You can see here, there's a bunch of information here that's output. So that thing right there is the owner of the directory. Right? So I own my own directory. Right? The things over here, these indicate the permissions that I have and that everybody else who might have access to this operating system has with respect to that directory there. Right? So I'll explain what these mean shortly. Right? But I own that directory. If there was another user on this, if I added another user to this Linux installation, they would also have a directory somewhere inside the home directory. Now, the owner of a file has control over access to their own files. Right? So whatever files a user has, they can control the access to those files. Right? So for example, it's possible for the owner to grant access to a file to all other users or to certain groups of users. Right? So for example, if I wanted to, I could give any other user on this computer or on this Linux installation access to this folder or this directory. Right? I can give them read access. I can give them write access. Right? There's also a notion of things called groups. So this middle or this second Burton here, this is the group that's the group ID of this directory. Right, so that directory belongs to the group Burton. I don't know why there's a group named me on this computer. That's just the way it works on Ubuntu. Right, so there are users, there are groups, and there's everybody else. Now, the groups aren't that interesting to us in this course because only a system administrator is able to make new groups. Right, so only so a regular user can't create their own groups on a Unix like OS. All right, so if you want to know something about a user's identity, you can use the command ID. It's not the most common command around. Let's take a look at what it does. So man ID. Right. So it prints the real and what are called the effective user and group IDs. So let's just try it. So ID, right? You can see that there's a bunch of stuff, right? Let's do ID my name. Let's see what happens. You get the same thing? Yeah, you get the same thing. Okay. So you can see that the IDs, they're just integer values. Right? So UID, that's the user ID, right? So apparently the user ID 1000 is me, right? GID, that's the group ID, right? It's also 1000, so that's me. Right, and then you can see all the groups that I belong to. So I belong to this group called Burton. I'm also part of the group ADM. I think that's short for administrator. And then there's a bunch of other groups which are created by are part of the Ubuntu operating system. If you're on a different Linux or if you're on a Mac, you're going to have different group names because every operating system does things slightly differently. Right, things like CD-ROM, that just gives me access. That's a group that happens to give me access to the optical drive on my computer. Right, floppy, I think, is the group that gives you access to a floppy disk, which I don't have, so it's unusual that it's here. So you're depending on your version of Linux, you're going to get different groups here. Okay, so what we're really interested in, though, are the permissions or access rights. So a user has control of different access rights on any file or directory. So there's 3 different types of permissions that you can control on any file or directory. So the 3 permissions are read access, write access, and execution access. Now these all mean very specific things, and they mean different things depending on whether or not it's a file or directory. So if I have a file, right, so let's look at the first column here. So I have a regular file that's not a directory, right? Suppose that I have read permission on the file. Right? Then that lets me open the file and read the contents of the file. If you don't have read permission on a file, then you cannot open the file and look at the content of the file. If I have write permission on a file, that means that I can write to the file or I can truncate the file. Right? So truncate means set the size to 0. Okay? Now, what it does, this is interesting. So what it does not allow you to do, it doesn't let you delete the file or rename the file. Right? So I can change the contents of the file, but I cannot remove or rename the file. Right? And I'll explain why you can't do that in a moment. And finally, if you have execute permission on a file, that allows you to run the file as though it were a program or a script. Right? Now, if you take a plain old text file, right? So a file that's just got some, some text in it of some kind, it's not a program of any kind, and you set its execute permission, right? You can, the operating system lets you try to run the file as though it was a program, right? But when you actually try to run it, nothing will happen, or you'll get an error because it's not actually a program. So just because you set execute permission on a file doesn't mean it's actually a program. It's just a permission associated with the file. All right, now if you have a file that happens to be a directory, these read, write, and execute things mean different things. Right, so if you have a directory that you have read access on, that means you can list the contents of the directory as long as you also have execute permission on the directory. Right, so you need both execute and read permission in order to list the contents of a directory. If you have write permission on a directory, that's what allows files in the directory to be created, deleted, or renamed. Right? Again, though, you need execute permission on the directory. Right? Now, why? If you have read permission on a file, can you not delete or rename it? Right? And so this all goes back to, I think, 3 lectures ago, where we talked about the file system. Right? So remember, on a Unix-based file system, right? Every file has an inode, right? So the inode points to where information on the file. The inode points to where information is information for the file is stored on your device, right? But remember that the inode does not contain the file name for a file, right? So that's why you can't rename or delete it, right? It's because the inode doesn't have any information about the name of the file. Right? So remember what a directory is on a Unix-like operating system. So a directory is just a regular file, right? But it's basically a table having 2 columns. Right? So in the first column is the file name, and in the second column is the inode corresponding to the file. Right? So that's why you need write permission on the directory in order to rename a file, because the file name lives inside the directory file. So you need to be able to write to the directory in order to be able to change a file name. That explains the difference here. Now, finally, why do you need execute permission on a directory in order to read the directory? Because execute permission, that's what allows a user to enter a directory, right? So if I'm in a directory called, well, let's look at an example here. So I'm in the home directory. Right? There's my directory in the home directory. Right? I have execute permission. That's what that X means, right? On that file. Right? If I strip the execute permission off of this, so I'll show you how to use this command in a second. I've removed execute permission on that directory. And that means that I cannot go into my home directory right now. So if I try to do this, it'll say permission denied, right? And that will also prevent me from listing the contents of that directory, right? So notice that you get a bunch of permission denied here, right? So you can't access, you can't list anything about the files in the directory, right? You can list what's there, right? But I can't list any information about a particular file in the directory. So you can see what's, you can list what's there, but I can't list anything in particular about any of these files. At least I'm not supposed to be able to. All right, I have to restore permission on that directory again so that I can actually go into it. Okay. So there's a command called touch that lets you create an empty file, right? So touch followed by a file name will create the file if it doesn't exist. If the file exists, then it changes the access and modification times of the file. Okay, so let's look in. So in this directory, I've only got these. I've only got these two files. Right. If I write touch file1.txt, then file1.txt appears. Look at the long listing for the file. Right. You see its size is 0, so it's an empty file. And you'll see right there, that's its modification time, right? So it's 151, right? So you can see that the last time this file was modified was at 151, right? Now, notice the other two files that I produced at the beginning of the lecture, their modification times are 134. If I touch one of those files, right? So if I touch the cow.txt file, then you'll see that its modification time will be updated, right? So now it's modification time has been updated to the current time. Right. So that's what touch does. Now I'm going to use touch to create a bunch of empty files later on in this lecture. Makedir is the command that lets you make a directory. Again, in this directory, right, I have no directories. Right, so everything just appears in white text here. I guess the other way I should, so hang on, let's do this. ls-l. Okay. I'm going to make a directory first, and I'll show you something. So make dir 1. So if you just, so if I list the contents, depending on how your shell is configured, this may or may not appear in color. Right? It might not appear in color. It depends on how your shell is configured. If you list the long listing of a directory, then a D will appear at the front. Right? So anything with a D indicates that file is actually a directory. There's no D here. If it's just a dash, it's a regular file. Right? So makedir is the thing that you use to make a directory. You can make more than one directory at the same time. Right? So I can make dir 2, dir 3, dir 4. That makes those 3 directories at the same time. If you want to, you can make a directory within a directory. So inside dir 1, I'm going to make another directory, ABC, right? If I list the contents of dir 1 now, you'll see that there's a directory ABC. Now, makedir is a little bit funny because what you can't do is that you can't make a directory and a subdirectory at the same time. So I'm going to try to make dir 5, and inside that directory, I'm going to try to make the directory ABC. So that doesn't work. Okay, so it complains it can't make that directory, no such file in the directory. So it's complaining that there is no directory dir 5, so it can't make the directory ABC inside that directory. Right? If you want to make if you want to make a directory with a subdirectory in it, right? There is an option that you can pass to makedir. So you can write makedir -p, and that will make a directory and any of its parent directories if it has to. So that's what the -p means. It makes make the parent directories as well. So if I do that, that will work. Right? I can now ls, and there's dir 5. Just the contents of dir 5, you'll see that there's a directory ABC. You can find all that out by reading the man page for makedir. Okay, so here's the long listing format, right? So when you use ls with -l, that produces what's called the long listing, and it produces extra information for all of the files and directories. Right? One of the pieces of information that it produces are the permissions of your files. Now you have to be careful with -l because every different version of Unix or every different version of Linux is allowed to change exactly what's listed when -l is used. Right. So in other words, there's no fixed format for the long listing. Right. So you are not. So when you're writing a script or when you're writing a shell-based program that you're going to use on many different operating systems, then you're not supposed to try to parse the output of -l, right? Because it's not the output you get from -l has no fixed format. Okay, so long listing. So here I've got a file called file1 in a directory somewhere, right? And this is what you see when you use -l, right? At least on my version of Ubuntu, right? You get some stuff here, you get something here, you get some more stuff here, right? So that first hyphen, that's the file type, right? If it's a regular file, it's a hyphen. If it's a directory, it's a D. And there are other different types of files that you can have. But for now, we're only interested in hyphen and D. Oh, here we go. I've got a bunch of them. I've got the whole listing for them. So L is what's called a symbolic link. We'll look at that later on. If you see a C, that's what's called a character special file. So that's a file that handles data as streams of bytes, right? So for example, the terminal is one of these character special files, right? So if you poke around on your operating system, you'll actually find on a Linux operating system, you'll find a file that corresponds to your terminal, right? So in other words, there's a file somewhere that corresponds to this thing here, right? And you'll see that beside it, it'll be labeled with a C, right? Its first letter will be a C. And finally, there's a block special file, and that's a device that handles data as blocks. So for example, if you find the file that corresponds to your to one of your disk drives, that'll have a B beside it. What we're really interested in are the things that follow the file type. Right? So today we're interested in the permissions. So the next three symbols are the permissions for the user, right? So if there's, they're always in the same order. So they're read, write, and execute, right? So if you have read permission, if the R is there, then the user has read permission. If the W is there, then the user has write permission. If there's an X here, then the user has execute permission, right? If there's a minus, that means that the permission is not granted, right? So I do not, I don't have execute permission on that file, right? Which makes sense because this is not a program. Right? This is just a plain old text file that might have some information in it, but it's not meant to be an executable file. So there they are again, right? So R means read, W means write, X means execute, right? The hyphen means no permission, or the permission for that particular, for either read, write, or X is not granted. Now, the next three, they mean the same thing as the first three, except they apply to the group, right? So that I also, so the group for this file is also me. So, or also, it's also the group named Burton, sorry. So the group has read permission on it, but any member of the group does not, sorry, any member of the group can read the file, but they cannot write or execute the file. Finally, there's the world. So this is everybody else, right? So anybody that's not the owner or not part of the group, right? So anybody else is able to read the file, right? But they can't write to the file and they can't execute the file. So that's how you interpret the permission symbols on the in the long listing. The number here, 1. So this is what's called the number of hard links. We haven't talked about links yet. So for now, that's what it is. And I'll explain what links are later on. Oh, actually, sorry. I'm going to tell you what a link is right now, but we're not actually going to go into any detail here. So a hard link is a directory entry that associates a file name with an actual file in this file system. right? So if there's a 1 there, that means the directory, in the directory, there is a listing for that file name, right? So there has to have at least one hard link for the original name of each file, right? What this is trying to tell you is that you can have several different file names in a directory that all point to the same file, right? So here's file 1, right? So it only has one name in the directory that points to file 1, right? To the contents of file 1, sorry. Right. It's possible for me to make other files in the directory that all point to the same, that all have the same content, right? So they all point to the same inode on the disk, right? So if I change one file, all the files are changed at the same time, right? There's actually only one file. It's just that it has a bunch of different names that point to the same file. The next piece of information is the name of the owner of the file. Then it's the group. Then it's the file size. The file size is normally measured in this thing called blocks, I think. If you want the human readable, so if you want the number of bytes, you have to pass in -h to see the actual number of bytes. And finally, there's the modification or creation date time, right? So this is the, if you created the file but you haven't edited it yet, then that's the creation time. If you have modified the file, then that's the modification time. And finally, that's the file or directory name that's actually in the directory. Right? Okay, so the user has control over how over the permissions of any file. Right? So the user is able to change the permissions on a file. The way you control permissions is with the ChangeMod command. So there's a bunch, ChangeMod is a funny command because there's a whole bunch of different ways to use it. Which ways am I going? Okay, so the first way, oh, there's two. No, there's one. Okay, so the first way I'm going to show you how to use it is with a number, right? So it's in octal, which I'll explain in a second. Okay, so let's see. So remember, you've got read, write, and execute permissions, right? So you've got 3 permissions that you can change, right? And you have 3 different groups, or so you can change it for the user, the group, or the world, right? So if you represent false with binary 0, and you represent true with binary 1, right? Then to change the read, write, and execute permissions, you need 3 bits. Right? So the first column here, right? That's the read permission, right? So if I have a 0, then that means there's no read permission. If I have a 1, that means there is read permission. Right? Now the second column, that's write. That's the write permission, right? So a 0 indicates no write permission. A 1 indicates you do have write permission. Finally, in the third column, I've got execute permission, right? So if there's a 0, you do not have execute permission. If there's a 1, you do have execute permission, right? Now notice to generate every possible combination of permissions, I need 8 different. So you can represent that with an octal value, right? So octal is base 8, right? So your digits in base 8 are the numbers 0 through 7. So ChangeMod can use an octal value to set a permission. So to set one group of permissions, so for example, imagine these are the permissions for the user, right? And I want to give the user read and write access to a file. And I can use the octal value 6 to give the user read and write permission. Right? If I want to give them all permissions, I use the octal value 7. Now notice that these combinations, not all of them make sense, right? So for example, 2, right, really doesn't make any sense, right? I can't read the file, but I can write to it, which is strange, right? So I can add stuff to the file if I want to, but I can't actually read I can't actually read the contents of the file. Having just execute permission is also weird, right? I can't read the file, but I can try to run it as a program. So that's strange. Right, and so is trying to write or execute a file without having read permission. So these are all a bit weird. Anything in blue is something that makes more sense, right? So it makes sense that I can only read a file, or I can only read or execute a file. Those make sense. But the ones in black, those don't make a lot of sense. Okay, so remember, I can use this octal value here, right? Center permission. Okay, so if I write ChangeMod 400 file1.txt, right? So what does the 4 mean? Go back to the handy table. It means, oops, sorry. It means write permission only. So this means give the user write permission only on file1.txt, right? Group and the world, they don't have any permissions on that file. 4.4 means give everybody read permission on file1.txt, right? But they don't have write or execute permission. 7.5.5, well, what's 7? So 7 is everything, right? And 5 is read and execute. So I'll give the user all permissions on this directory. Give everybody else read and execute permission on that directory. So that lets anybody else on the system go into this directory and read what's in there. So that's using the octal value. Okay. Now, there's also a symbolic representation that you can use with the ChangeMod command. So the symbolic representation uses 3 symbols. So the first symbol is a U, a G, an O, or an A, right? So this lets you set either the user, the group, other, which is world, or everybody, right? So A is all, right? So I can set the permissions for just the user, just the group, just other, so not group, not user, not group, and everybody. Right? So you use one of these symbols here. You can actually use a combination of these symbols if you wanted to. Next, it's plus, minus, or equals. Plus means add a permission, right? Minus means remove a permission, and equals means assign a permission, right? So for example, suppose I'm a user and I have read permission on a file, right? So I already have read permission. Then if I write plus R, sorry, I don't have read permission. Sorry, I have read permission. I don't have write permission on it, right? So if I write plus W, that adds, that gives me write permission on the file. Right? So it adds that permission. Right? If I already have write permission, then nothing happens. Right? And that actually does an assignment, so that sets the permission to whatever value. Right? And then finally, the third symbol is whether you want to set the read, the write, or the execute permission. Right? So one of these, one of these, one of these, or some combination of these. All right, so here we go. So ChangeMod plus R fname. All right, so if there's nothing in front of the plus sign, right, then by default that sets all users, right? So that changes the permissions for all users. So plus R means give everybody read permission on that file. If you specify something in front of the plus sign, then it's only this that's changed, right? So U plus W means give the user or add write permission for the user. Right? Minus means remove execute permission from the user. You can group the different permissions together, right? So A equals RWX means give everybody read, write, and execute permission on that file. Right? And similarly, you can use commas to separate things, right? So if I want to if I want to add execute permission for the user, I write plus X, right? And then comma G equals RX means give the group read and execute permission as well. So add execute permission for the user, set read and execute permissions for the group. Right? Now it doesn't matter which one of these which form of ChangeMod you want to use, right? Use the octal values, right? Or you can use the symbolic values, right? Both are commonly used. I personally find the symbolic ones easier to remember, right? So I'm not very good at remembering what the exact octal values do. And so I tend to use the symbolic version instead. Let's see, what time is it? 2:10. Okay. So that's what you need to know about setting permissions on files and directories. You can set the permissions on both files and directories. Right? All right. I guess now I'm going to introduce expansions. And then in the next lecture, I'm going to show you what the other expansions are. So for now, so we've used star before. Star and question mark, we've seen those already. Right, so you know that star will match all files in a directory. So for example, so there's ls. Okay, so if I write ls star, right, star means match anything in the directory that's not a hidden file, right? So it doesn't begin with a period, right? And you can see that it does something slightly different than just ls on its own. When I write ls star, you see that it prints out cow text file one text fortune.txt. When it prints out dir1, it also lists whatever's in dir1, right? And when it prints out dir2, it lists what's in dir2, right? When it when it lists dir5, it also prints the contents of dir5, right? So if I just write ls dir5, then right, this is the output that's produced. So when I write ls star, right, I get the same output for dir5. Okay, so ls star and ls are slightly different then. The output that they generate is slightly different. So ls lists the contents of a directory, right? ls star lists information for each file in the directory, right? So it lists information for cow text, file one text, fortune.txt, but then it also lists information about dir1, right? So when you type in ls followed by a directory name, it lists information for that directory. If I ask ls for information about two different directories, right, then it prints out the directory name and the contents of that directory, right? Prints out the directory name and the contents of that directory. Right? So if I do one more time, ls dir1, dir2, dir3, dir4, dir5, oops. It lists each directory and the contents for that directory, right? But ls doesn't do that, right? ls just lists the directory name. So when you do ls star, what's actually happening is the following, right? So when you type in a command and press enter, bash performs what's called a substitution on the text that you typed in before executing the command. Okay? So when I type in ls star, right, bash substitutes something for the star, right? The thing that gets substituted is all of the file names that are in the directory. So when I type ls, right, these are all the files that are in the directory. When I type in ls star, right, that's the same thing as typing in lscow.txt, ls dir1, ls dir2, ls dir3, dir4, dir5, file 1, and fortune, right? That's the exact same thing. Right? They produce the exact same output. So what the shell is doing, it's taking that star, right? And it says, well, what does star mean? Star means match every file in the directory, right? So it matches that, it matches that, it matches that, it matches that, and so on and so on and so on, right? So it matches all of those files. So it just replaces the star with all of those file names here, right? And that's why it produces this output. So there is an example of an expansion. So the process of performing a substitution is called expansion, right? Now, an expansion involving a wildcard, right? So anything involving the star or the question mark, right? That's called a path name expansion, right? It's called the path name expansion because the star and the question mark, they expand to file names. The command echo is a command that prints its string arguments to standard output, right? So if I write echo, this is an echo. And all it does is print out, this is an echo, right? Doesn't look useful, but it turns out this is how you print stuff from a script, right? So if you need to generate something from a script, then you can use echo to generate the output, right? Okay, path name expansion occurs before a command is executed, right? So what does that mean, right? Okay, so I'm going to make another directory here, and then I'm going to create a bunch of files, right? So file2.txt, file3.txt, and fruit.exe. There are my files. So if I echo f star, right, what does that do, right? So what does the star do? Well, f star means match any file, right, that begins with the letter F, right? So that's what it means. So echo f star means, right, so after you type it in and press enter, path name expansion happens, right? So the star gets replaced with, f star gets replaced with file2.txt, file3.txt, and then fruit.exe, right? So in other words, echo f star is exactly the same as I typed in that. It means the exact same thing. If I do echo file question mark dot text, right? So this is going to be another path name expansion, right? So what does file question mark dot text match? Well, it matches file2.txt and file3.txt, right? So this should print out file2.txt and file3.txt. So in other words, that's exactly the same as if you had written that. Echo fr star. So once again, right? Path name expansion, right? So that happens before echo runs, right? What does fr star match? Well, it matches fruit.exe, right? So that prints out fruit.exe, or, right? Which is exactly equivalent to doing that. Now, what happens? So this is the interesting part. Now, what happens if I type in echo g star? So you might think, so hang on, let's do this. Oh, that's right. So there's no file called that begins with a capital G, right? So you might think that this is going to give you an error, right? Because G star doesn't match anything, right? The star doesn't match any, there's no file or directory that begins with a capital G, right? So you might expect to get an error, but you don't, right? Star. Right. So you have to be a little bit careful when you use commands and you combine them with a wildcard expansion or with a path name expansion or any other expansion for that matter. Right. The expansion happens before the command is path name expansion happens before the command is run. Right. So G star, well, that doesn't match anything. Right. So instead of performing the path name expansion, right, because there is nothing called G star, right? G star gets passed to the echo command as input instead, right? Which is why you get that as the output. So you have to be aware of that the shell is always going to try to do this path name expansion, right? So if you have an input to a command that has a star or a question mark in it, right? You have to make sure that you have to make sure that you understand whether you want the star or the question mark to be expanded using a path name expansion or not. All right, so that's it for today. There's actually a bunch of different expansions and that I have to tell you about. So we'll do that in the next lecture. All right, anybody have any questions about today's lecture? Okay, I'm not seeing anything. So I am going to end the lecture there. Spend the rest of my day marking deferred exams. Hopefully you have something more fun to do. But that's what I'm doing with the rest of my day.